Okay, we are live. I think we are good. Sound is here. So yeah, finally have time to back to the last Rust programming book. And now we continue with the structures as I see. We passed through ownership, which was quite unique and complicated topic. I think we will need back to it time to time. So yeah, because I don't feel I like clearly understand everything there, and it might make more sense after some practice. So for now, just keep going forward to get more pieces of the Rust language. And yeah, as I said, today it's structures, so let's start. A struct or structure is custom data type that let you package together and name multiple related values that make up a meaningful group. If you're familiar with object-oriented language, a struct is like an object data attributes. In this chapter, we will compare and construct tuples with structs to build on what you already know and demonstrate when structs are a better way to group data. Well, we'll demonstrate how to define and instantiate structs. We'll discuss how to define associated functions, especially the kind of associated function called methods, to specify behavior associated with a struct type. Structs are enums discussed in chapter 6, so this will be next. Structs and enums are the building blocks for creating new types in your program domain to take full advantage of Rust's compile time type checking. So yeah, basically, if you from some other programming languages, you maybe expect something what struct should be if it's like your first programming language and just start reading the book. The struct, it might be something similar to the tuples, but maybe with some additional features. But I think we will get it really fast when we start moving through the section of this chapter. So let's start with defining and instantiating structs. Structs are similar to tuples discussed in the tuple types. Basically, data types is section 3.2. And this is the tuple. Struct are similar to tuples in that both hold multiple related values. Like tuple, the piece of struct can be different types. Unlike with tuples, in struct you'll name each piece of data, so it's clear what the values mean. Adding these names means that structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the value of an instance. Okay, so let's quickly jump on the example. Unlike the tuple, we have a name for each field, and since we have names, we can access it through names, and we don't need to rely to the order. If we back for a second to tuples, will be like we can access the values through the index, so we need to know this field was the first, this was the second, etc. But in struct we have the names, so I guess we can access through the names. To define a struct, we enter the keyword struct and name the entire struct. A struct's name should describe the significance of the piece of data being grouped together. Then inside curly brackets, we define the names and types of the pieces of data, which we call fields. Okay, for example, this listing show a struct that stores information about user account. So as usually, we see some piece of code, we want to try it. So basically, let's quickly, I have new project, and so I guess it shouldn't be defined inside the main, it just can be put on top, struct user, like this, something active boolean, it's just bool, sorry, username string email, sorry, I messed up with a lot of languages and syntax sometimes just drop out my head and I mixed everything, but I think sign in count. Let's do something our way, just use size, so it will depend on the architect. And of course there is a typo. Okay, there is some new error, but we don't care about it. Let's do cargo run. There is a warning that we defined the struct but never used, but no errors, it's running, so far so good. We define a struct. To use a struct, after we define it, we create an instance of that struct by specifying concrete values for each of the fields. We create an instance by stating the name of the struct and the add curly brackets containing key value pairs, where the keys are the name of the fields and the values are the data we want to store in those fields. We don't have to specify the fields in the same order in which we declare them in the struct. In other words, the struct definition is like a general template for the type, and instance field in that template will particular data to create values of the type. For example, we can declare a particular user as shown in listing 5.2. So basically we don't worry about the order, and we just create each field with values. So let's do it quickly and see if we have any problem. So user curly brackets, let's try to mess up with the orders. So start with sign in count equal 1, then yeah, active, let's say it active, then yeah, basically username string from demadev, and what left is email. It's not my real email, so don't worry about it. Okay, no else pairs, so let's do cargo run, and yeah, it doesn't do anything, but it's compiled and run, so we are good so far. We just testing how to identify, and what we read is like the order isn't matter. And there's a lot of warnings actually. Let's okay. Fields are never read. Okay. Yeah, it's a bit annoying, like we just have done anything with it, but yeah, there is full of warning. But maybe it's something we will get used to it in the future, or maybe some change of the file default behavior of the yeah Rust analyzer. But actually I'm thinking in the TypeScript I have similar config, so it shouldn't be a problem. Let's continue to read the book. So to get a specific value from a struct, we use dot notation. For example, to access the user email address, we use user1 email. If the instance is mutable, we can change a value by using the dot notation and assign it into a particular field. Listing 5.3 shows how to change the value in the email field of a mutable user instance. Okay, now we can access and mutate, but for this we of course need to make our struct mutable. So let's do mutable user1 and then user1 username equals string from demadev 2, for example. So maybe we can even print it out, like to see username before and after we did the change, so kind of do some testing. This is really work. And you see username was demadev and then demadev2. Yeah, nothing surprised, but just checking what we are doing, that we understand it correctly. Everything good. Note, the entire instance must be mutable, so yeah, it's not just one field we do mutable all the struct fields. Rust doesn't allow us to make only certain field as mutable. As with any expression, we can construct a new instance of struct as the last expression in the function body to explicitly return that new instance. Listing 5.4 shows a built user function that returns a user instance with a given email and username. The active field gets the value of true and the sign-in count, sorry, get a value of 1. And of course, let's write that function. So fn build user. Yeah, I see Copilot already will to fill it up, but let's do it ourselves. Email. I'm kind of lazy. Let's still be one parameter. So we have build user. Now we can do just user email, then just copy everything. And since we don't have semicolon here, it's return. If we do this, nothing return, like empty tuple or unit type. So, but still, yeah, we miss the return type here. Much better. And let's do user2 string for user from build function. And of course we want to print it. Call the run. Yeah, we see demand, but yeah, we actually put the email, so email is what we're looking for here. User from build function. Okay. This looks good. There is some shorthand struct initialization. This is interesting. I think we will read about it soon, but it looks like the feature in JavaScript where we can maybe do something like this. Oh, really? It works? Nice. Yeah, I really like this. This is great. I never saw it anywhere as outside of JavaScript world, but I think it's just nice. It worked very well for me in TypeScript code, TypeScript, JavaScript, whatever. So yeah, it makes sense to name the function parameter with the same name as struct field, but having to repeat the email and username field names and variables is a bit tedious. If the struct had more fields, repeating each name would be even more annoying. Luckily, there is a convenient shorthand. So I think this is what we just tried. Yeah, you see, if the name of the field structure same as the name of variable you pass into this field, you can just avoid do it like this. You can just write it once, you know, don't need to email, just okay, we know these emails come from previous entrance of email variable. Great feature. Nice. completely agree with creators of the Rust. This is nice one. So let's read it. Because the parameter names and the struct field names are exactly the same in listing 5, or we can use the field init shorthand syntax to rewrite build user so it behaves exactly the same but doesn't have the repetition of username and email as shown in listing 5.5. So yeah, basically shorthand for username and email, since we have variables with in this case it's function params, but it could be variables created not from the params, whatever, and we don't need just write it twice. Here we're creating a new instance of user struct which has a field name email. We want to set the email field value to the value in the email parameter of the build user function. Because the email field and the email parameter have the same name, we only need to write email rather than email. Yeah, amazing. Create instances from other instances with struct update index. It's often useful to create a new instance of a struct that includes most of the values from another instance, but change some. If you can do this using struct update syntax. First, in listing 5.6, we show how to create a new user instance in user2 registry without the update syntax. We set a new value for email, but otherwise use the same values from user1 that we created in listing 5.2. So let's create another user and use fields from the previous user to fill part of parameters, like part of fields. Yeah. And it will be user3. Yeah, let's, as Copilot suggests, rewrite a mail. It will be no dev +3 at gmail.com. So we need the comma here, and after we will have username, and we have to username same as user1 username. Then active is same story. And what else? Sign in count. Sign in count, user1. Okay, let's print the result. Let's print email and username. Username. Clear console. Cargo run. So you see user3 is daemon dev +3 as we defined here, and username is daemon dev2, which has come from mutable user1. So we set the username here is daemon dev2, and then we use it in our user3 for define initialization. Okay, let's continue. Using struct update in the syntax, sorry, we can achieve the same effect with less code as shown in listing 5.7. The syntax thanks period, two periods, how it's called in English. Okay, two dots. Specify that the remaining fields not exactly set should have the same value as the fields in the given instance. The syntax specified that the remaining fields not explicitly set should have the same value as the field in given instance. So let's of course try this one, and let's try with user one, cargo run. We have same result. Let's try with user 2. As you see, I'm way more faster for changing things in the user 2 creation because of this feature. But by the way, it was correct. Yeah, Dimado. Okay. What I wanted to try is the I didn't get where the order is meta. Can we do sorry. Can we do it like this? Can it use a comma after the base struct? The base struct must always be the last fields. Okay, so it should be always last one. And actually we can format it with cargo fmt. Okay, it complains about the comma. So cargo fmt, and we need to refresh the buffer, and you see it's formatted. If you use me familiar with JavaScript, well, it's like Breiter or linter, yes, linfix, something like this. So yeah, this is actually amazing. I didn't expect to have such feature in the Rust, and I'm starting to understand what is its most loved language in the Stack Overflow survey, because it have really cool like syntax features apart from its safety, efficiency, but it also made in the way it support the developer to write the code in more easy way. I would say it's clear, understandable, and easy. I mean, this periods feature and this shorthand field init shorthand. So these two I just love. So yeah, let's continue. The code in listing 5.7 also created as instance in user2 that has a different value for email, but has the same values for the username, active, and sign-in count fields from user1. The user1 must come last to specify that any remaining fields should get their values from the corresponding field in user1. But we can choose to specify values for as many fields as we want in any order, regardless of the order of fields in struct definition. So yeah, as we find out, this this feature basically to.user1 should go last always without comma, but we can use any fields in any order before. What will happen if we define all of them? Like if we do active false and sign-in count 2, and what left? Username is anything. Maybe try to run it. It's no complaint here. There is an error, but maybe we just need to restart our analyzer. New Vim, so yeah, it's gone. Okay, yeah, I kind of expect it will notify me. There is, I don't do anything with this action, but kind of the same, I guess. What happened? Yeah, no errors as well. What? But yeah, okay. No, the struct update syntax use equal like an assignment. This is because it moved the data, just as we saw in the variables and data interacting with move. Oh, so we're moving our data, and this is our ownership topic here. So when we have note that the struct update syntax uses, okay, struct update syntax is basically this syntax, and it's mean that we move the fields. It's actually not affects primitive types, or how they call it, I remember. But yeah, the one that we have in stack, like boolean and u size in our case, will not affect it, but the strings, if we do move, we can't really use it anymore. So let's, I guess we will have the error if we'll try the print user2 username, because we used it already. So user2 username value borrowed here after move, and value moved. Oh, the error is quite nice. It's like says this username value was borrowed after move, and it shows where it was done. It was done here in this struct, particularly is with this, how it called again, struct update syntax. This kind of okay. So we use it like this. We moved some fields. Now the user2 is unusable. I feel like my code completely messed. Not sure how this affects the Rust coding, but yeah, we see the ownership is really important concept which we have to face in each step of the coding in Rust. Yeah, I think we will understand in future how this affects us, but for now, for me, it's not looking great. But yeah, I think we just need to live with it and we understand how it works. In this example, we can no longer use user1 as a whole after creating user2 because the string in the username field of user1 was moved into user2. If we had given user2 new string values for both email and username, and thus only used the active and sign-in count values from user1, then user1 would still be valid after creating user2. Both active and sign-in count are types that implemented the copy traits, so the behavior we discussed in the stack only data copy section would apply. So yeah, we don't move ownership for sign-in count and active, so this should still work. So let's try sign-in count. Will it produce any errors? Let's clear console and run. Yeah, you see it still works. The ownership is still there. Using tuple structs without named fields to create different types. So there is some structs with tuples. That's interesting. Let's read about it. Rust also supports struct that looks similar to tuples, called tuple structs. Okay. Tuple structs have the added meaning the struct name provided by provides. The struct name provides, but don't have names associated with their fields. Rather, they just have the types of the field. Tuple structs are useful when you want to give the whole tuple a name and make the tuple a different type from other tuples, and when naming each field as in a regular struct would be verbose or redundant. To define a tuple struct, start with struct keyword and the struct name, followed by the types in the tuple. For example, here we define and use two tuple structs named color and point. So you see here we can always just use this one, but yeah, it's predefined type, and it's more prominent that we store in this tuple color and in this point, but basically the type underneath is same, but meaning of these values, like purpose of these values, is different. So yeah, and like it's predefined type, so we don't need, like when we initialize it, we don't need to write the type again and again. So let's try it as well. Struct color. Struct point is the same. And what we're gonna do here is, yeah, let black color 0, 0, 0, and let origin also 0, 0, 0. Note that the black and origin values are different type because they instance of different tuple structs. Each struct you define is its own type, even though the fields within the struct might have the same types. For example, a function that takes a parameter of type color cannot take a point as an argument, even though both types are made up of pre-i32 values. Otherwise, tuple structs are similar to tuples in that you can restructure them into their individual pieces, and you can use a dot followed by the index to access an individual value. So the point is, yeah, we cannot assign a color to a point, like, I don't know, let point can I actually mismatch type? Yeah, it's right. Origin, so origin, it is fine, but I cannot assign color to point, and this is something we talked about the purpose of the type, but we still can use it as tuple point x is 0.0, and we are good here. Okay, unit like structs without any field. Oh, this is something interesting. So unit is a tuple without any unit. It's basically, here's the unit. By the way, it shouldn't produce any errors, right? Yeah. So this is empty tuple is the called unit type in Rust. So struct which don't have any fields, any tuple like empty tuple, unit like structs. So you can also define struct that don't have any fields. They're called unit like struct because they behave similar to unit type. The unit type that we mentioned in the tuple type section, yeah, of course we read about it in the chapter 3 section 3.2 data types. There is the tuple type, and somewhere here is unit. Yeah, the tuple without any values has a special name, unit. So it's it's kind of could be feel annoying to read everything, like if you know other programming languages and okay, data types is just there is array, there is a boolean, but there is some specific of languages, and if I just jump over the things I kind of know from the different languages, it will not work because I don't know what is unit type. What I will struggle reading new information here. Yeah, so what I'm saying is it's not like a fast process. You should go step by step, like don't expect fast results, but I feel like at least with Rust is the right way. Just read whole the book from the beginning to the end. This is my feeling so far, and yeah, I'm really excited doing this. So sorry, let's back to the book itself. So unit like struct can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. Okay, the struct where we don't want to store any data. Okay, we'll discuss traits in chapter 10. Here's example of declaring and instantiating a unit struct named always equal. I don't know, let's quickly use it, but maybe, as it said, we understood it later with traits in chapter 10. So far it not bring to us any value. We have a variable subject always equal. We can create it, but I don't really know what to do with it. Okay. To define always equal, we use the struct keyword and the name we want and then semicolon. No need for curly brackets or parentheses. Then we can get an instance of always equal in the subject variable in a similar way. Sorry, was distracted for a moment. Then we can get an instance of always equal in the subject variable in a similar way using the name we defined without any curly brackets and parentheses. Imagine that later we will implement behavior or for this type such that every instance of always equal is always equal to every instance of any other type. Perhaps to have a known result for testing purpose. Yeah, maybe for some testing purpose could be used. But yeah, I can't really clearly imagine purpose of this right now, but I'm sure we will see it. We just when will be the right moment where we have more information about other part of the language, we will understand it. So like we learn about structs, we learn about this particular feature. We can't really use it now, but in future we have a reference, like if we need, we can go back, we know where to find it very quickly, and read it, refresh it in memory, and start using it with full power. So we wouldn't need any data to implement that behavior. We'll see chapter 10 will come up, and how to define traits and implement them on any type, including unit like structs. Ownership of the struct data. Yeah, this is also we mentioned that ownership will come to us again and again. At least I expect it from what I read so far. In the user struct definition, in listen 5.1, we use the own string type rather than the... Yeah, this is how it was called. I guess it's slice type. Yeah, string slice type. Let's quickly check it to refresh the memory. The slice type. String slices. Oh my gosh, I feel almost lost, like since I don't know, it was a week since I read it. Other slice. So yeah, this is basically string slice. Okay, yeah, it's written here, it's string slice type. Sometimes I just need, don't think too much and read and to the end of the sentence. String slice type. This is deliberate choice because we want to each instance of this struct to own all of its data and for the data to be valid for as long as the entire struct is valid. It's also possible for struct to store reference to data owned by something else, but to do so require the use of lifetimes, a Rust feature that we'll discuss in chapter 10. Lifetimes ensure that the data referenced by a struct is valid for as long as struct is. Let's say you have to store a reference in struct without specifying lifetime, like the following. This won't work. So basically, yeah, the reference like string slice and but we kind of don't have an owner. Like usually when we have a owner, then we give a reference to someone to use the value of some variable, but with owner, and by owner we knew how long it lives. But here we don't have an owner, and then we don't understand when it will be destroyed. I guess this is the point. The compiler will complain that it needs lifetime specifier. Expect name lifetime parameter. So again, this is some reference for future. We will learn about something new in chapter 10, and we can back and try to store some reference in our structs. For now, we mark this as something we will learn in future. Something like this. Okay, we're done with section 5.1, and section 5.2 is called an example program using structs, which looks quite exciting. Let me have a sip of water. Yeah, I'm not usually talking a lot in my daily life, but streams this is essential skill, so I'm learning. And I must say water helps a lot. So an example of the program. We are programmers, we want to write the programs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We'll start by using single variables and then refactor the program until we are using struct instead. Let's make a new binary project with cargo called rectangles. I'm doing it right away. So do this one. Cargo new rectangles. Change directory rectangles and vim. Main rc file. Clear hello world print, and we are ready. That will take the width and height of the rectangle specified in pixels and calculate the area of the rectangle. Listing 5.8 shows a short program with one way of doing exactly that in our project. So what we're doing here, we have two variables, width 1 and height 1, okay, and then we print result of area function, which is, let's try to write it ourselves. We know what we should write, so we need width 1, for example, and height 1. Then let's create a function, area, that takes uct2 height will be same, and we want to return value will be the same type, and simply multiply widths and heights, and then we can try to print sorry. I don't know, just the area and area invoke width height. And I already kind of see a problem here. Like we have width and height, and we have same params for the area, but generally if we messed up with it, like if we put height here and it's here, the result will be the same, but in this particular case, but if we expect a result which will be different, where we mix the arguments, it's easy, like when you write it here, if you don't see exactly this function declaration, it's super easy to mess up. Because type are right, but yeah, but we mess up logically. And I think this is something that Struct actually can fix for us. So let's move forward. Yeah, I think we forgot to run it. Yeah, the typo here, the area. Now this program using Kagura, this code succeed and figure out the area of the rectangle calling the area function which with each dimension, but we can do more to make this code clear and readable. The issue with this code is evident in the signature of area. The area function is supposed to calculate the area of one rectangle, but the function arrow has two parameters, and it's not clear anywhere in our program that the parameters are related. It would be, yeah, this kind of what I'm talking about. It's just put some variables that have same type, but they kind of disconnected. Yeah, could be disconnected. For now, it's like really simple program, and we see what's going on. Easy to identify the problem. We can cover it maybe with test, but yeah, it would be more readable and more manageable to group width and height together. We've already discussed one way we might do that in the tuple types section by using tuples. Refactoring with tuples. So, okay. Let's do next version. I don't want to remove it yet, but rect. You see, now it's even less clear. What is width, what is height? Not sure how cool it is. And area direct And what we do, zero rect. Yeah, I'm doing a lot of React, so something inside me trying to write React instead of Rect. Okay, so this is what we had to do. Yeah, it said dimension, but generally, yeah. In one way, this program is better. Tuples let us add a bit of structure and we are now passing just one argument, but in other way, this version is less clear. Tuples don't name their elements, so we have to index into the part of the tuple, making our calculation less obvious. This is exactly, it's less obvious. Mixing up the width and height would matter for the area calculation, but if we want to draw the rectangle on the screen, it would matter. This is, yeah, what I'm saying. We would have to keep in mind that width is a tuple index 0 and height is the tuple index 1. This would be even harder for someone else to figure out and keep in mind if they were to use our code, because they haven't conveyed the meaning of our data in our code. It's now easier to introduce errors. So refactoring the struct added more meaning. We use struct to add meaning by labeling the data. We can transform the tuple we're using into a struct with a name for the whole as well as names for the paths as shown in listing 510. So finally we are close. We are now using struct. Okay, I think I'm ready to remove everything here. Here and start from scratch. Construct rectangle width u32 height same, then Jesus, I did it again. I just can't write React. I'm writing React. So React angle rectangle width 30 8. Let's write something else because it's become too boring. Okay, then we need the function area which receive rect suggests a reference, but what we have here, yeah, we use a reference. And now rect width on the rect height, and of course return type is missed. This is like I get used to in TypeScript, it automatically understand what return type it should be, and in most cases you kind of fine, not specified explicitly, but Rust is a different story. We will get used to it, I guess, when we will write more Rust code, not just like reading book, but and we learn more and we write more exactly the code. I hope our streams will be like that. So let's clear. And we are good here so far. Here we defined a struct and name it rectangle. Inside the curly brackets, we define the fields as width and height, both of which have type uct2. Then in main we created a particular instance of rectangle that has width of 30 and height of 50. Our area function is now defined with one parameter, which we've named rectangle, whose type is an immutable borrow. And this is, as usual, an important part of a struct rectangle instance. As mentioned in chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retain its ownership and can continue using rect1, which is the reason we use the ampersand in function signature and where we call the function. Yeah, this is pretty straightforward. We don't want to move ownership inside the function. It just calculates. Don't do anything. In this case, it might have this mutable reference, but still, we are fine here. We don't want to move the ownership, that's why we pass the reference. The area function accesses the width and height field of the rectangle instance. Note that accessing fields of a borrowed struct instance does not move the field values, which is why you often see borrowing of structs. Our function signature for area now says exactly what we mean. Calculate the area of rectangle using its width and height fields. This conveys that the width and heights are related to each other and gives descriptive names to the values rather than using the tuple indexes. This is win for clarity. For sure, this is super clear compared to the previous one. In first example it was kind of clear as well, but there is different problem we discussed, like you can mess up with the data. Adding useful functionality with derived traits. Okay, like in previous section it said we heard more about traits in chapter 10, but there is something as derived traits. Okay, let's find out. It may be beautiful to be able to print an instance of rectangle while we are debugging our program and see the values for all its fields. For sure. Tries using println macro as we have used in the previous chapters. In all chapters we are using it. This is our like main tool today. And this won't work, however. Okay, this is unfortunate. Like, yeah, I would like to try it. I know it will not, but this is the best way to learn it. Just try things. Rectangle cannot be formatted with the default format. This is it. Doesn't implement std fmt display. Yeah, here it is. This error, and this is the pointer where it happened. In format strings, you may be able to use or for pretty print instead. This error originates. Yeah, let's try it. Pretty prints sound pretty, so run. No, it still says we cannot do this. Oh, yeah, we haven't read it to the end. So consider annotating rectangle with derived debug. And I think this is what we will read about. The println macro can do many kinds of formatting, and by default the curly brackets tell println to use formatting known as display output intended for direct end user consumption. The primitive types we've seen so far implemented display by default because there's only one way you want to show a one or any other primitive type to a user. But with structs, the way it should format the output is less clear because there are more display possibilities. Do you want commas or not? Do you want to print the curly brackets? Should all the fields be shown? Due to this ambiguity, Rust doesn't try to guess what we want, and structs don't have a provided implementation of display to use with println and the curly brackets placeholder, empty curly brackets placeholder. If we continue reading the error, we'll find the helpful note, which we did. In format strings, you may be able to use, pretty print. Let's try it. The print line macro call will now look like this. Put in the specifier. Set the curly brackets tells println we want to use an output format called debug. The debug trait enable us to print our struct in a way that is useful for developers, so we can see its value while we debugging our code. Compile the code with this change thread. We still get an error. Yeah, we did it and we get an error. But again, the compiler gives us a helpful note. The trait debug is not implemented for rectangle. So add derived debug to rectangle or manually implement debug for rectangle. Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the alter attribute just before the struct definition as shown in listing 5.12. So, okay. Yep. The right debug. Save and yeah, let's clear and run. And voila, it works. Nice. So now when we run the program, we won't get any error and we'll see the following output. I actually want to try, okay, yeah, this one, which is pretty print. Oh, it more styled now. Very pretty. Okay. Yeah, and so nice. It's not prettiest output, but shows how. But it shows the values of all the fields for this instance, which would definitely help during debugging. When we have larger structs, it's useful to have output that a bit easier to read. In those cases, we can use, yep, in the println string. In this example, using style will output the following. Yeah, we got it. Another way to print out a value using the debug format is to use the dbg exclaim mark macro. And here is the reference. And okay, dbg, something a bit cryptic here, but still. Let's back to book. Which take ownership of an expression as opposed to println, which take a reference print the file and line number of where that dbg macro call occur in your code along with the resultant value of that expression and return ownership of the value. Calling the dbg exclaim mark macro prints to the standard error console stream as opposite to println, which point to the standard output console stream. We'll talk more about std_err and std_out in the, okay, it's even further in chapter 12, writing error messages to standard error instead of standard output section. Okay, so yeah, for sure we have to try it. Here's an example where we are interested in the value that gets assigned to the width field as well as the value of whole struct in rect1. So what we have to do here, dbg macro in action. Let's, can I just do something like this? Yeah, we put the reference here. Print the same, but it says reference rect. What if you remove the reference?
Okay. I guess in case we remove the reference, it will move our ownership, and we cannot do this after anymore. And if we put the reference here, oh, sorry. And in this case we are fine. Yeah, this is great to understand that we, in case dbg macro, we need to use reference, like preferably we should use it. We can put dbg around the expression. Oh, there is even stuff like this. Yeah, this is something new. We definitely should try it ourselves. So we have scale, we have width as 30 multiplied by scale, and then there is dbg around it. Okay. And here's the output. It's actually looks super cool because it prints what you put in the dbg macro, and like you don't need this to write this prefix to understand what you are printing. Just exactly say you put 30 multiply to scale and it equals to this value. I think this is great feature for debugging, of course. We can put dbg around the expression, and because dbg returns ownership of the expression value, the width field will get the same value as if it didn't have the dbg call there. We don't want dbg to take ownership of rect1, so we use reference to rect1 in the next call. Here's what the output of this example looks like. Yeah, sure. We can see the first bit of output came from line 10. Yeah, it's also print the line number, so let's try it again. 30 multiply scale is line 10 in our case as well. Okay. The debugging expression, and its resultant value is 60. The debug formatting implemented for the integer is to print only their values. The debug formatting implemented for integer is to print only their value. Okay. dbg call on line 14 of src main output the value of reference rect1, which is the rectangle struct. The output uses the pretty debug formatting of the rectangle type. So yeah, dbg use debug. It's guess it's called trait, and we will learn it later. But this macro, it's not macro, it's how it's called. It's derived traits. Okay, it's traits, but it's derived. Not totally sure what it means, but basically what it do, it add some additional implementation, like if you know some object-oriented programming, if you have interface with declaration of function, and you can have actual implementation like in, I think there is in different languages, it even there is a keyword implementation. Yeah. So in the implementation, basically implement some function. So these things implement some function which displays our data for us. It's not information, like it's my assumption. It's like not a new for sure, but I assume it's works like this. So let's back to what we were reading. Yeah, this is what we're talking about. This is output use the pretty debug formatting of the rectangle type. And in the errors before, like we see, if we don't have it, it says it's not implemented to show anything like this. DBG macro can be really helpful when you are trying to figure out what your code is doing. Yeah, for sure. In addition to the debug trait, Rust have provided a number of traits for us to use with the derive attribute that can add the useful behavior to our custom types. Okay. Those traits, yeah, basically traits. We don't know yet what it is, but I guess it's some sort of implementation. Those traits and their behaviors are listed in Appendix C. Okay. Okay. We'll cover how to implement those traits with custom behavior, as well as how to create our own traits in chapter 10. There are also many attributes other than derive. For more information, see the attribute section of rough reference. Yeah, basically clicking everything to like become a bit more familiar in advance, that when we face it next time, okay, I already seen this, and this will help us like it's just easier when you have some see something what you saw previously. It's easier to understand. Sometimes it doesn't make any sense. You think, okay, attribute chapter 7, we will be there after. Okay, oh, it's not the book, it's what is this? Or is books? This book, the primary reference for the Rust programming language. It provides three kinds of. Wait a second. Is it same? Docs, Rustland, or book? This is something else. I think it's just docs. It says it also books, but oh, warning, this book is incomplete. Documenting everything takes a while. See GitHub issue what is not documented in this book. Okay, okay. Rustling reference. Okay. But I guess this is something that it's more like documentation than what we are reading now. This book is like documentation book. Okay. And yeah, you see, we didn't really dive in what it says about this attribute section, but we find out there is another book. There is something we can look into when we need it. There's small like hooks we like send for our future use. Okay, our area function is very specific and only compute the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work with any other type. Let's look at how we can continue to refactor the code by turning the area function into an area method defining on our rectangle type. Oh, we can have a method for the struct. Okay, I think we will back to the methods on the next stream because I feel it will not be as productive as on start. So thank you guys. See you next time.